right, let's go ahead and get started. I want to thank you for coming tonight. And I was just going to start with a brief overview of the Research Park. How many of you work in the Research Park or think you may work in the Research Park and don't know? Okay, go ahead and put up the next slide, please. So I'm Jamie Jarvis. I'm the Director of Programs for Stanford Research Park. This map may answer your question of whether you work in the Research Park. We have about 140 companies here and 29,000 employees. We have 7 mobility companies and about 3,500 employees working for them. I'm going to try and name them. If I do it in alphabetical order, I may remember them. If I miss one, help me figure it out. So there's Argo AI, there's Autonomic, there's Ford, there's Luminar Tech, there's Lyft, there's Uber. That's 6, so I've forgotten somebody. Starts with a T. Kind of a high-profile CEO. Something's going on with their stock this week. It'll come to me later. So we do have 7 companies, mobility sector, and that's kind of what made us think about when we're doing our very first speaker series, let's have something on that topic and bring in some real experts on that. I did want to say a little bit about my broader team. You met Amy and Elin out at the check-in. Amy runs the SRP Go transportation program. So that's our commuter transportation program that gets people to the research park in shuttles and carpools and van pools, support bicycling program. Very proud to say that in the 3 years since we've been doing that, we have reduced drive alone by 10 percentage points. So measurable results, valuable service to commuters, benefits to the community and the environment. So we're happy to have that program in place. I was also happy to see that the bike rack out front is full. So some of you biked over, which is great. Elin, who's also on my team, is now taking on, for 2020, we're launching these learning initiatives. And we're doing a combination of midday lunch and learns, a couple of those every month throughout the Research Park. Anybody's invited to them, so you'll be hearing more about those if you work here. And then this is our inaugural speaker series. So very happy to have you here for this. Next slide. All right, at this point, I'd like to turn it over to Jarvis. He's going to welcome you here to Ford. I want to thank them for having us here. Great facility, right in the heart of Research Park, so very convenient for everybody. Thank you.
Thank you, and welcome. Yes, I'm Dragas Machuca. I'm the Executive Technical Director here. Really quick background on where you guys are. So first of all, Ford started in the Valley about 7 years ago. We started in downtown Palo Alto. 5 years ago, we moved in the Research Park across the street. We started with about 5 people, and now we have about 330 or so in these 2 buildings. And it's been a really exciting journey, especially in that intersection between automotive and Silicon Valley. Like when I joined 5 years ago, I was still being asked, what the hell is a car company doing in the Valley? It's like, aren't you sheet metal benders? What the hell are you doing here? Throughout the years, quickly auto tech became a thing, and we started getting really well integrated in this whole ecosystem in the Valley. And that to me was very important, to make sure that we are really well integrated in the Valley in terms of working with VCs, working with startups, and more importantly, working with the universities, Stanford and Berkeley and the other universities in the ecosystem. And again, as you almost feel it in this space, transportation as a whole is changing tremendously. And a lot of the signals are starting from here. And a lot of the stuff that's happening here, we're actually feeding it back into our headquarters. We have also been part of the CARS program at Stanford almost from the beginning. In fact, Chris Gerdes and I are colleagues from Berkeley from a long time ago. So it's been a nice journey to come back to my roots in terms of autonomous vehicles. And then today we're happy to host you guys here, and hopefully this is going to be one of many that we're going to host. And we do open up this space to a lot of meetups, a lot of other events for the community. So I'm sure some of you have been in other events. And of course, if you have an interesting startup, let us know. We'd love to hear. Thanks.
Thank you. Now I'd like to introduce Dr. Sven Beiker, founder and managing director at Silicon Valley Mobility. And he's going to say a little bit about the Society of Automotive Engineers and then also kick off our panel. Thank you. You need this or you might? All right.
They won't hear me. Great. Thanks. Yeah. Hi there. Well, thanks very much for the warm welcome and also for the invitation, obviously, to kick off this speaker series. Before we dive into our technical topic, testing and simulation of autonomous vehicles, I want to do a little bit what John Tintinelli would have done if he was here today, but he's doing fine, but he had to return to Detroit, Michigan for a family emergency. And so many of you know John Tintinelli. That means you also know that that picture does not do him justice. His hair certainly is much more, shall we say, innovative, growing strong, and he's quite a good sport. And his mission was, until now, also to establish SAE International here at the West Coast a little bit more. And he also is part of this IAMTS, which is an International Testing Proving Ground Association. He's very active in that as well. But as you can see here in the gray, there's actually copy-paste from his LinkedIn. He's also now moved to Europe to actually develop SAE's activities in the future mobility topics there a little bit more, which means that I will be working very closely with John Tintinelli at least throughout this year and help SAE International here on the West Coast to move things forward. And in that capacity, I'm telling you a little bit more about SAE. It won't be too long, I think 4 slides or something like this. But I thought it's maybe good to start with my own connection to SAE International, which is this. And I know I don't look great on this picture. Chris Gerdes looks much better. But that's actually an award that Chris Gerdes' team and I earned in 2008 for a paper that we published in 2006 at the SAE World Congress. And it's the Arch T. Coldwell Merit Award, which I needed to say when that was awarded to us. I was like, what? What is it? And maybe that's actually a little bit symptomatic of SAE International, which is like, yeah, people know about it, but quite frankly, how much does it matter and how much is it actually about the future of the automobile as opposed to having gotten the automobile to where it is today? And that's also, I guess, the mission that SAE International now has here on the West Coast, to actually connect with people, startups, tech companies, and certainly the traditional automotives as well, to figure out, okay, how can we be a driver in figuring out future mobility going forward? Because everybody knows SAE with their standards. You might say, okay, that's tedious work, but I guess those of us in the automated driving field certainly use it every day with the levels of automation from 0 to 5. So don't say it's 5 levels of automation because there's 0, it's actually 6 levels. And it has been refined since, I think, 2014 when it came out, and also SAE acknowledges it's not perfect, but it is being used, and that's actually where SAE sees itself, like being a sounding board, being a body, like bringing a group of experts together to figure out what is actually unanswered and where do we actually need some more structure. And another one which is maybe a little bit less known in the automated driving community, but for sure not less important, is actually the work that was done in a standard called J1772, which actually defines what a plug for electric vehicle charging should look like. Most EV companies actually subscribe to this and use this plug. And otherwise, we would have a situation, every different electric vehicle might have a different plug. So I guess we can say there's pretty important work happening there. One other work, which is a little bit of a video backdrop, is actually what led to the publication of these papers that we have here. And there you can tell that John actually has full hair and very innovative hair. It's his back head here. And that we actually worked on, okay, what about sensor testing and edge cases and everything, and how do you test an automated vehicle? And quite some of you actually here today, the panelists were part of it, Atul, Paul were part of it, Dave was part of it, and a few others of you as well. So therefore, first of all, great to have so many expertise and also volunteering. And because what came out of it is, for one, this paper that is unsettled issues in balancing virtual, closed course, and public road testing of automated driving systems. And the other one is about what is the modeling fidelity that you need for simulation. So basically, how detailed, how accurate, how good, how complicated does your automated driving simulation need to be? And as you can tell from the first line in either case here, and feel free to grab one of these copies later on, it's unsettled issues. So we really see something that is rapidly happening, like automated driving. Obviously, it's really hard to keep track of things, but they're unsettled topics. For instance, everybody talks about this is how we will eventually prove safety of these vehicles. And others say, yeah, that's fine, but we do it slightly differently. Well, is that a good situation if you have a lot of opinions, beliefs, and processes, or should it be more combined? And therefore, these publications are different. They are different from the standards that SAE is known for. They're different in a way they tend to ask all these questions, but don't really aim to give all the right answers. So therefore, we have these publications here, and they also actually gave input to our panel topic for today, which I want to intro maybe for about 10 minutes or so, and then we'll invite my four panelists here on stage to discuss with us how safe enough and how to prove that. And there's one thing, even with automated vehicles, there will be unfortunate incidents, hopefully just minor fender benders, but there might also be worse. There's one that you find when you look for autonomous vehicle crash, and then this comes up, obviously a Waymo incident that happened in Arizona. Actually, I had not heard much about this, but you find this picture and it makes the point. So really the question to be asked is, how safe is safe enough? That is actually one of the most often discussed questions in bodies like this, and that's what we will be discussing here in the panel discussion. And whenever I go to a professional meeting or conference, or even like discussing automated driving over coffee or maybe a slightly more powerful beverage, then it's like, well, how do we do this? How do we make sure it's actually safe? That we want, or that we think we are ready to bring it to the roads and get closer to this great vision that those of you who've been with me for some time know that I'd like to show this picture because it's almost as old as I am, the vision of automated driving. And the question to be asked, will we ever get there, that we can actually go behind a nice video monitor and just play cards or something like this and enjoy the drink? And I took the quote here from the CTO of the Audi Automated Intelligence Driving Group, I think that's what it's called, where it's all about 90% and 95% and how many nines do you want to add to it. So basically saying getting to 90% is fairly easy, getting to 95% starts to get interesting, and then you still need to go way beyond this, 9.999 and many more nines. And adding each additional 9 is 10 times as hard. Okay, that's maybe the answer of an academic, an engineer, someone who's really good at numbers. But I'd like to maintain, or actually challenge this. Do we actually know what we are shooting at? Do we know what 100% is? Because it's really something like, what is driving? And this is where we can get very philosophical if we actually understand what driving an automobile is. And still, what we use quite often in order to show progress are miles driven. And this is in logarithmic scale down here, where you basically see the Waymo has now accomplished 20 million miles driving on public roads, and estimates are maybe about 15 billion miles in simulation. Tesla Autopilot, maybe it's about 2 billion miles that have been driven under Autopilot. And then in blue, you see the statistics here when actually something happens. This is how much a typical light-duty vehicle drives per year, 11,000 miles. And all the way to the top, you have the 3 trillion miles, the total number of road transportation that we see in the United States every year. And since this is logarithmic, you can now ask yourself, okay, that's great. Much more than any single vehicle drives per year, but still does it measure up against the total amount of miles that we have? And then one certainly needs to say, well, but just counting miles, are these miles all equal? Does it not matter under which circumstances you're driving those, weather, traffic, road type? And then events are randomly distributed. If you reach, like, let's say, your 100 million miles, which is cited very often for something, how often a fatal accident occurs. Like, if you do 100 million miles, is it good? Because these events might be randomly distributed. And also the actual number, if you want to get beyond this, is maybe way too high for testing on roads, which is why simulation obviously matters a lot. And that's about the number of miles. So when we then look into this and ask the experts, such as Dmitry Dgolyov, the CTO of Waymo, he's pretty bullish on miles. This was still from summer last year when they were at 10 billion miles in simulation, 10 million in driving, where he says the amount of driving you do in both of those is really a function of maturity. So how much you drive defines how mature your system is. Okay, that's a point. Why not? And then we asked Chris Urmson, the CEO of Aurora, where he says, well, it's really an easy metric that you use, which is the number of miles driven. However, the problem is that it's getting lost what kind of miles we have, because obviously you can do 1 million miles on an empty road, or you can do maybe 1,000 miles in downtown San Francisco, and certainly you will see very, very different things. And I guess many of you, if not all of you, have driven an automobile before, and certainly it's very different to drive on the highway compared to driving on city roads. Now, but we will see something like this within the next week, which is the disengagement report that the California Department of Motor Vehicle will publish again, because it's mandatory that everybody testing automated vehicles in the state of California has to say how many miles total they have been driving under autonomous testing conditions, and how many disengagements they've had. And this is really what they file, and this is where we should leave it. But then the media and analysts, including myself, I confess, then cannot help it but really divide this and say who's better than anybody else. Waymo is very much on top, certainly with the most miles, and the most miles in between disengagements. And this is where you see Cruise, and this is where you see Aurora. And the reason why I added Cruise to it, because, and those of you really into the field probably have been following over the last few weeks, that the industry is now getting ready to receive the grades. And in anticipation of the grades, those who are probably not at the very top of this metric of sheer number of miles, they explain it. They explain it why they are not on top, or at the very top, but why they are still pretty good. Which, for instance, why Cruise, so General Motors Autonomous Driving Group, basically says, well, in a few weeks, so this was just, 2 weeks ago, something like this. In 2 weeks, the California DMV will release those disengagement data. The data is really great for giving the public a sense of what's happening. Unfortunately, it has also been used in a not so great way. So where you see, just to put out a number, like we have driven so many miles, and this is the number of disengagements that we have in between, that makes companies nervous. And probably it should make consumers nervous as well. Certainly for the companies, it is they are then getting compared, and then the stock price might get affected and something like this. But also for consumers, it's like, we drove all these miles, but what is this telling me? I drive a lot of miles. I'm not in an accident, but can I still trust this thing? And also Aurora, Chris Urmson basically says, soon be made public in the California Disengagement Report. And it's actually, what he says, rapidly losing stock in the conversation around how we should measure progress, because we actually need to have a distinctive definition of progress that is really paramount. I certainly don't disagree, but how do we define this? And how do we make sure that when eventually those vehicles will come to the market and the conversation goes like, well, is this self-driving thing actually safe? And the salesperson, or sales robot probably, will say something like this, oh sure, the manufacturer says it's the safest car out there. Would you believe it? Maybe. Depends on the manufacturer, right? If the manufacturer has a great track record of safety, I'll probably tend more to believe it than maybe if there's a vehicle manufacturer that's known for crappy products. Also, the answer might be, oh, sure, the average rating on the web is like 4.5 stars, like an Amazon sort of measurement. And that's really crowdsourced, and everybody who drives this car clicks on it. Is that something where you say, yeah, I buy this book because it's 4.5 out of 5, and I also buy this car because some people who I don't know say it's safe. It could also be something where you say, sure, it passed all the tests recommended by the Agency for AV Safety. That does or does not really exist. It might be NHTSA, it might be someone else. Maybe an agency that we will launch here tonight, who knows? But then that's recommended and they actually exceed this. Or it could be something like, well, it actually surpasses all the mandated testing requirements, where you see the difference obviously might be in the fine print. Is it just recommended or is it mandated to do this? And therefore, there you see already there's a lot of discussion. How do you actually also make sure that the customer understands it, that this is safe or not? And as I see my two great friends from AAA here in the first row, we've been working a lot on this, like, how do we actually explain to consumers this is a safe product? It's really a huge question. And when I just look at this, full disclosure, I put it together this morning, I thought about it. You know what? It comes probably in different stages. At the very beginning, if there's no automated vehicle out there, it could be that something like this is pretty good. Where you say, okay, a government agency says this is safe. But as we move further into autonomous driving land and there's a ton of vehicles out there, you might trust something like this because they, oh, government, you know, has a relatively low bar. Everybody passes it. But I really trust what consumers say. You could also maybe trust this manufacturer and say, yeah, if they say it. So it's not the same to every people. It's not the same depending on where we are in the process. But this is exactly what we wanted to do with these two papers, where we discuss it basically, how do you test those vehicles and what matters in simulation. And before we dive now into the discussion with our panelists, just a little bit more about the process that we also thought about when we had this workshop actually that was showing the video of at the beginning. What does the development process of automated vehicle testing actually look like? Because there's a lot how you can do testing. You can do something like this, you can do something like this, you can do this, or you can do that. Which basically means the question is, how do you get from a great idea of automated driving, like I envision a self-driving car, I want to make it work. How do you get to an actual product that you can sell on the market that gets certification and also good approval ratings then on the market? So you can start with a lab tinker setup where you cobble something together. You can do a little parking lot demo. You can do closed course testing and open road testing. That's basically what it is. And you can different things there. It's maybe one is more for just sensors and some architectural questions. One is to show the whole concept, but really not in a public setting. Then on a proving ground where you can have very repeatable setting, or on public roads where you get to these unexpected scenarios, edge cases, something like this. So where you see already there's many different reasons why you want to do one and not the other, or why you might want to do all of them, because after all, it's certainly a process that flows in this direction. And as nice and linear as it looks, is actually quite a puzzle that you need to solve, because it's a repeating circle. You cannot just start at one point and then say, now I went through these 4 major sets and now I'm done. And what you also need to consider that it's actually not just in the real world, the same thing actually happens in the virtual world as well, where you say, yeah, everything what you can do here, like you put some technology together, you try it out in a parking lot, you get on a test track, and then you get in the open road. You can do all of this in simulation as well. And those of you who are really into it, that's basically the V model of product development that's behind this. So with this, I think we should really get into our discussion. And I want to invite now our great panelists to the stage. It's Alexander Kraus, Senior Vice President Automotive for TÜV Süd. It's Georg List, Vice President Corporate Strategy at AVL. It's Robert Seidel, Managing Director, Motors Ventures, and it's Thomas Bock, Director, Vehicle Integration and Testing at Samsung Smart Machines. Some of these companies you've maybe never heard of, or at least you don't recognize them immediately, so therefore I also added the logos for some context, and so that you know a little bit more what we're talking about, and the panelists are going to introduce them as well. And the nice thing is, we're all German speaking. Deswegen machen wir das Ganze jetzt auf Deutsch und wir hoffen, dass ihr das trotzdem alles gut versteht. Passt, oder?
Super.
All right, great. Thanks for our panelists. Thanks very much for being here. Maybe we just do a quick intro. Alex, let me start with you. What brings you here today? Why are you excited about automated vehicles? And tell us a little bit more about TÜV Süd.
Well, thanks, Sven. Hi, everybody. My name is Alex. I studied automotive engineering in Munich, Germany, and I'm actually working for a 155-year-old company that is dealing from day one with safety of technology, so that technology is not harming people or environment. And I'm running a team of roughly 1,500 people all over the world, engineers that are exclusively dealing with safety of automotive. So from component to full vehicle level. And of course there are traditional technologies in automotive from traditional OEMs and so on. But in particular, we also really work with partners like AVL, Georg will introduce himself in a minute, to, let's say, invent the new methods and metrics and tool chains and infrastructures that we need to certify at the end to prove safety of automated and connected vehicles. So it's a fantastic thing. I do that with passion and I'm happy being here.
Great, and you guys are based out of Munich, Germany, but you do have local offices here on the West Coast and certainly Midwest, is that correct?
Yeah. In the US we run a team of also about 1,500 people, but we do testing and inspections and safety assessments of practically all products you can imagine in all industries. And in terms of automotive, we're also here and also in Detroit, Michigan, and we are running a couple of labs across the US.
Great. Thanks so much. Georg, tell us more about yourself and AVL.
Thanks, Sven. Georg List. I'm working with a company called AVL, and why am I here is because AVL does automotive testing and simulation tools. And we apply it, so we're a big engineering company also, with about 11,000 people, mostly engineers and scientists. So we don't produce anything other than test beds, a little bit of software. I'm passionate about what I do too. I have a day job that is, I'm responsible for strategy at AVL, which in these dynamic days is not so easy anyway. But secondly, also in my night job, I'm responsible for ADAS testing, ADAS and AD testing and research and technology at AVL.
Great, and you also got offices here in Silicon Valley, I think, right?
We have an office in Silicon Valley, we have a tech center in Southern California, and we have a tech center in Michigan.
Great, thanks. Robert Seidel.
Austrian.
Yes.
You're saying you come from Austria because everybody thinks we're from Germany. We're not. We're from Austria.
So I said German speaking, not German, right?
It's almost the same, I would say.
Anyway, hi, I'm Robert Seidel. I'm with Motors Ventures. My background is in software, and for about 7 years, Motors has invested in autonomous vehicle technology, sensor technologies such as lidars, radars, ultrasound systems, cameras, but also tooling, like a simulation company called Meetup, because we realized that this is a really big problem, and all the miles you've seen up here, those were the miles physically driven. Those are kind of the tip of the iceberg miles. And so there is going to be a change from the mechanical engineering world of validation verification to the software kind of verification validation, which is very different. And so Meetup, as a simulation company, I've been quite busy with as well. And they do simulation verification for sensor people, for self-driving cars, trucks, forklifts, sidewalk robots, industrial robots, all kinds. Everything from the raw perception to the whole behavioral modeling and testing. And I think that's going to play a much bigger role, and that this is part of it. But where exactly are we shooting, and what's the right tooling is still a lot of open questions to be answered.
Great, thanks. And you've been around in the Valley for what, 20, 25 years?
30 years.
30, yeah. Wow. The Valley
I did my own
back
companies
then?
before,
Okay.
so yeah.
Good, great, thanks. Thanks so much.
You're still Austrian at heart.
I'm still Austrian.
Thomas, good to have you. Samsung Smart Machines, tell us more about that and what you do.
Thank you, Sven, for having me here. So currently working still for Samsung Smart Machines. We are developing an SoC-based ADAS solution. I'm in charge of bringing this into our cars and testing our cars, going to Momentum and other places where we test this out. I'm very passionate about that the system's engineered correctly and that we are going out and know what we are testing, know what's implemented. So I'm coming from the engineering side, really on the V model side, and going up the right side on the side, making sure whatever is written down is really tested. So that's my passion. Came here 21 years ago, so it's almost half my time after leaving Germany. It was right around the corner on Page Mill Road, where Mercedes had an office, and worked 19 years for Mercedes, half the time on telematics infotainment side. Then when they opened the office in 2013, switched to the autonomous driving side and worked on level 3 autonomous driving on the highway, tested at that time on 101, 280, our highway chauffeur pilot pre-development platform, and then switched to the urban automated driving pilot. It's together done with Bosch, driving in San Jose around. Just launched their first public pilot last year, so I'm very proud of being part of that and I helped Samsung in terms of building up their vehicle fleet and started testing. Unfortunately, our office is closing.
Yeah, thanks very much. So Daimler, Mercedes-Benz, Samsung, and currently in transition. I think that much we can say. Yeah, okay. Great, thanks very much. And so we certainly prepared some questions, but we also definitely want to discuss with all of you. So let's say we probably take about 20 minutes or so to go through some of the questions that we prepared, and I'm curious myself to see how it goes. And then please have your questions ready, and we have mics that we will pass around. So I wanted to start with a slightly philosophical question to really an invitation to also make maybe a personal statement. And this philosophical view goes like follows. So it's the year 2020. It's been more than 10 years that Google and Waymo has worked on self-driving cars. More than 15 years ago that we had the DARPA Grand Challenge. And still, I think that nobody came here today with a truly self-driving car. So what's holding us back? Why does it take so long to bring these autonomous vehicles to the market?
Well, let me answer that first one from my perspective. There are multiple reasons, of course. So first of all, the technological complexity is pretty high. So, and you gave you the answer in your introduction as well. So when you're reaching 95%, you're just scratching the surface. So the complexity is so high that we need new metrics, new tool chains, new methodologies to validate safety. And just imagine that vehicle, could be possible to come here with an automated vehicle just on a closed infrastructure to reduce the risk just by not allowing people passing the road or something. But this vehicle would have to really manage going through heavy traffic at a conjunction which is in a different condition every second, because you will never have the same situation twice. That is complexity coming from the environment, let's say, from the use cases as well. And certainly one big thing is there is no standard or regulation in place that simply allows to come with a fully automated car. So you cannot register it at the end.
Anybody else trying a shot? answering why we don't have those
I
vehicles.
think it's a little bit underestimated the complexity in terms of what the human brain is processing and how the human can perceive and see what the prediction of other traffic participants are, what you can do. People have looked at this in terms of, yeah, it's the driving rules, you can write this down and all this stuff, we can figure this out. It's just like giving a driver license to a 16, 17, 18-year-old human. But what they're forgetting, and they're quoting Philip Koopman here, is like in terms of they underestimate this human being has 16, 17 years of knowing, predicting people perception in the real world, and this is very hard to teach a computer on that part. And this is, I think, where the industry is a little bit scaling backwards, and so let's start with a more simpler way in terms of we are restricting our ODD in a certain way. That's like Waymo is doing in Arizona. We have a very fenced-in, flat, nice weather area where we can drive, and I think from there on we're going to go out and then expanding again to do more complex tasks.
So let's peel the onion maybe here a little bit. So after all, it's the automotive industry. It has been around for, give or take, 100, 120 years. And here we are, and we say, we are not quite sure how we test and certify those vehicles. So what's so different from everything that the automotive industry has been doing thus far? Like, come up obviously with crash testing and emission testing and vehicle dynamics testing and infotainment testing and whatnot. But now there seems to be something like back to square one. We don't really know how to do this. I don't know, AVL has done a lot of testing.
We've been testing for 70 years now. I think so. This is very different, and it's. I think, like Thomas says. First of all, we have to recognize that the human is an amazing species and can do lots of things. And we're not testing vehicles anymore, right? We're testing simulated humans. Very different ballgame, and. Quite frankly, we're also not so good at testing humans for their ability to drive. So we haven't succeeded, but you forgive that to humans more easily than to a machine. But if we look at it technically, I think it's the first time when we have components, systems, and systems of systems, which is really, again, a different ballgame. Hasn't been there before. This scenario-based thing that automated driving cannot be done unless it's done scenario-based or tested unless it is scenario-based is key. We've tinkered with scenarios, and if you think about how simple a WLTP or a NEDC, so driving cycles were, and how inappropriate they actually are to represent the real world, and we've already struggled with these. Now this is a whole new dimension. And then last but not least, self-learning and cognitive systems. How do you test them? And today they don't even necessarily change as they go, but in the future they will change as they go. And I think nobody has figured out how to interpret the learning and good or bad learning of these systems also yet.
So yeah, Robert, maybe also about simulation, since you at Meetup Motor are obviously very involved in that. But what's your take? Why is it so different?
Well, I just want to talk about something that's not technological, but organizational. And I think we see that the auto industry is a 100-year-old, very mature industry and has a deep supply chain. And you can see any organization reflected in the products that that organization makes. So when you look at an S-Class Mercedes, it has a very deep supply chain. There's Continental supplying stuff and Bosch and different people. So you have 100 ECUs that are in that, 100 computers that are in that car versus one domain controller, big fat computer in a Tesla. And the reason is that the organization hasn't restructured to face the new reality of being much or maybe even mostly software driven where the critical path is. And so a lot of the companies that you showed in your graphs up here, the bar graphs, the top bar graphs were all new companies comparative to the OEMs, the traditional companies. And I think Tesla wasn't on there, but Tesla is a prime example of mixing software with traditional car companies and re-architecting the organization as a human problem and the supply chain shortening as an organizational problem. So yes, we can talk a lot about the technical issues, but I think that organizational background plays a big role. And the car companies basically have just now pressed pause because too many changes are impinging on the traditional OEMs, the connected car, the electric vehicle, the autonomous, and basically they've serialized it now. They're going to do electric first, they'll keep everybody busy, not just the technology, but reorganizing the company, and then we'll do AVs, which actually will give these other companies, the newcomers, probably a little bit more air if they can survive the valley of death here for the next few years.
Right. Thomas?
The other thing people forget maybe about is like, until fully automated, going from level 4 and above, ADAS systems and any system always had the driver fallback. So basically, that's where in testing was like, oh, we can test it to this level. Then like, if not, driver takes over. There's always a driver who has to pay attention and doing this. So that was the easy out for the automotive industry. It's like also goes back to the driver, whatever our system cannot handle. And with a fully automated system, you cannot go that because there is no driver anymore.
That's right. I think there's really a huge difference, obviously, that needs to be recognized between ADAS, meaning advanced driver assistance systems, and really vehicles that don't rely on the human anymore. And yet, yeah.
I was just going to throw one more hand grenade in here, which is I think the V model of engineering is outdated. It doesn't work.
So what do you recommend? You cannot just say it's outdated. Bring it on, Robert.
So this is basically decompose everything. This is this waterfall model of engineering in software, which 20 years ago everybody, and myself included, were doing in our companies, where we had, for example, you build something, and first you have your specifications, and then you modularize it, and you get down, and eventually you have a C function, and then you have unit tests where the C function is tested, and then you have integration tests and so forth. The problem was, first it serializes everything, so you have a QA team that was a separate team, and so you would throw it over. The engineering team was done, and you throw it over to the QA team, and they would do the QA, and they would always be pressed against the wall of delivery times. And nobody nowadays does QA in software where the QA people are actually doing the QA work. They're all doing tooling, and the QA is being done while you develop. That's a huge change. The other change is the introspectability of the software that we have nowadays, all these deep networks. There's no C function that you can test anymore. You can test the whole behavior. So really what we should be testing is on the behavioral level before we start decomposing and testing C functions or Python functions or particular ECUs.
And then also as part of this, and true to the title of our event here tonight, testing and simulation. So what do you guys see, like how is that intertwined or separate or in serial composing? Like when do you do testing on the road and when do you do simulation? And what are respective strengths? So give us your understanding, your expertise. How do you balance, what also the title of one of our publications, how do you balance the real world versus virtual world in developing these vehicles?
Yeah, I'll throw a hand grenade now. My turn. No, there isn't an either or. And that's the determining factor, and this has been going on for a while now. This is not new. There is not, I do this in simulation or I do this in hardware. It's a blended testing. And I think the automotive industry has been actually quite good at blending that, which gives you a path of not having to be perfect instantaneously or before you get anywhere, but blending means you can take the best of both, or you have to take the best of both, and you can also emulate and stimulate, and build better models, etc., etc. So we use something that we call an integrated and open development platform, where you try and plug in, so to say, what you have in hardware and what you have in software, and build models around it and develop as you go along. As you said, it's not a V model anymore. It's blending simulation and testing.
And also related to this, so do any of you foresee like an ultimate state where it's only virtual testing, or will there always be test track and real open road testing?
I think sorry.
Yeah,
I
go
think
ahead.
that it's an ultimate goal, of course. It's what you strive for if you ever will get it. Like
But is it
cold
realistic?
fusion for energy, like carbon neutral. It's like that's what you strive for. I think there has to be a certain validation in the real world that your sensor models, your simulation models really match what's happening in the real world. How do you know if you're just putting all the models in simulation and do this? But certain thing has to be validated on the road that whatever you have simulated, be it sensors or models or behavior or whatever, is really matching the real world. And I think that's where the simulation engine needs to be kind of certified. This is really a safe stamp on there. And there is no process for this right now. Maybe
So
SAE can help in terms of certifying simulation tools for autonomous driving. In terms of this is really matching the real world.
So now you're basically saying, yes, you will need still road testing in order to certify and validate your virtual model. But once that's validated, you can basically do everything in the virtual world, is that?
Not necessarily, but it's like there's always the big iceberg underneath how much unknown, unsafe scenarios are still out there. You don't know. So
I do think it's asymptotic, though. In other words, certainly you want for validating your tools, because if you're spending 1,000 times more hours in the simulator than in the real world, you have to make sure that those hours are well spent and not just a cartoon. The second thing is you're always going to find yet another case that you didn't consider. This is Chris Urmson's grandma with the broom and the ducks in the road, that kind of thing.
We've all seen that video.
Yeah, I assume everybody's
adorable.
seen that. The third reason, I think, is the environment around us changes as we introduce things, and so we constantly have to update our equipment and our testing tools. For example, at the moment, we don't have really hybrid traffic. We have it's 99.9% human drivers, and so you have to take care of that because if you brake really hard with your AV, somebody's going to smash into your back. And San Francisco, as we get more mix, the mix changes, the validation procedures have to be adapted too, because they don't stay constant. So there is a constant need for making sure that the real world is reflected in the simulator. But I think the tip of the iceberg cost model and time model is also that you have to do simulation. You cannot drive all we need in the real world. There's just no way.
Alex, what do you think? Edge cases in the virtual world, will that work?
No, I think so one thing was said already by Thomas, so there will always be the need to qualify tool chains, simulation tool chains, and that's done by physical testing. There will always be the need to validate models and interaction between models, driver model, vehicle models, sensor models, and so on. But also edge cases need to be considered, and I believe that physical testing, and I would disagree for hardware, they still do it with the V process, so the hardware also needs to be tested anyway. Yeah. So this is still done. You can do probably hardware testing or testing on a proving ground by 10 to 2 different scenarios. But when it comes to high complex situations, you have to do it in simulation. Because then you can do 10 to X, whatever is number of scenarios you need to test. And don't forget that there's also HIL and ZIL and so on. So you do hardware in the loop testing and software in the loop testing, even function in the loop testing and so on. So I think there will always be the need for physical testing. I also believe that in the near future, let's say the next 20, 30 years, it will even increase the need to test because we have mixed traffic, because we have so different technologies. We have extremely different use cases. Just think about running an automated vehicle, which can be actually the same in Singapore compared to Alaska or something. It's so different. So this is still to be done on proving grounds, and you have just to see what the traditional OEMs are doing. I just saw, I've just been at Daimler in Germany. They have built the most crazy proving ground I've ever seen. They can do everything in Immendingen, in Baden-Württemberg. BMW is doing the same now in Czech Republic because they say we have to, before we deploy a vehicle to the road, we have to be sure that it is not killing people. So it has to be tested until certain metrics are reached before they deploy even prototypes or small serious vehicle, not thinking about serious vehicles to the open roads. So this will be done on proving grounds. So I think proving ground operators will be there for the next years, and the number of them is growing rapidly.
Yeah, absolutely.
One thing that I would like to add, I mean, proving grounds not the absolute most effective way of testing.
You're right.
So when I was saying blending, we can, for example, a small sidestep, but you can have a Formula One race driver in a simulator, driver simulator, and you can get on a real racetrack, you can chase him around the course by hundreds of seconds close to what he would really do. And that is by full simulation. Everything else, environment, car, engine, blah, blah, everything is simulated. Or you have the whole car in real on a test bed next to him, or you have the engine next to him. So you can really blend different things, which allows you to take the best of both, right? You can't have the best model, the simulation model that really gets you hundreds of the second close to it. But if you have the vehicle there, and you combine it with the simulator, then you get there. Yeah.
But Georg challenged this in terms of, I'm a big Formula One fan, and seeing this, and they always do before the season, they have their car, they know exactly how they build their car, they know the track, they simulate the track, and then they go out really, and they are a second faster for some reason. So like there is some difference in the simulation.
Contest that, but I'll invite you to Graz.
So let's maybe talk also a little bit how we can standardize this, because you brought up examples, Alex, for instance, from different OEMs, so vehicle manufacturers. We're talking about different test tracks. We obviously have one great test track here, Momentum, and CBRE. Matt van der Aar is working on things, and we have M-City, and we have all these different test tracks. And we have different companies working on their own testing methodologies. And we saw some say number of miles are important, others say kind of miles, type of miles matter. So how do we get to a world where things are more standardized, unified to an extent? Do we already have some of these measures? There's a lot of talk about ISO 26262, there's SOTIF and things like that. Tell us a little bit more how we get to a world where when people talk about the safety of automated vehicles, they actually mean the same thing.
Taking this first. It's more or less standards, but I think Chris or Sebastian Truhn said that when they were at Google at that time, basically, if our car makes a mistake, all the cars learn from this. And then what this was in the Google/Waymo case. And I would love to see the industry come together in terms of, hey, when one of the Waymo cars it discovers this scenario, it can also be shared with all the other, basically, that Cruise, Zoox, whatever you have, can also run the same scenario. That edge case they have not discovered yet. And this can be shared across the industry in terms of in a standardized way, that we have a standardized scenario database and can work off this. And then I think, as you had in your slide, in terms of then maybe the regulator can also take, hey, if we want to rate the safety of an autonomous driving vehicle, we can use that common database and we select these thousands of scenarios and then how good each company can go through those scenarios, and we have a standardized ranking between. Because then you go basically, as you did before, Waymo has so many miles, Cruise has so many miles, but you cannot compare those miles. Are they straightly delivering on I-5 or downtown San Francisco? It's completely different. But if you have a standardized way to measure it, and if the industry can learn together on their mistakes, that would be a way to standardize that.
Alex?
Well, I would like to add something on what you correctly said. First of all, there's a consensus around the globe. So we're dealing with all the OEMs from Japan to the US. Also, most of the big suppliers are our customers. And there's a consensus that we need some kind of global understanding in terms of metrics and when is something safe. So there's a complete understanding, and that leads us to a thing that is really missing, which is a bottleneck. I think technology is developing rapidly. We have many verticalized companies that have their own IP and develop their business models individual, and there are so many duplications of things, and there is so many lost energy, lost power behind it. What we need is kind of collaboration, let's say horizontal collaboration among different institutions that really deal not with developing technology only, because that's anyway happening, but with really defining the right metrics, tool chains, KPIs, infrastructures that are required to do the validation of safety or functional validation, whatever, and that needs to be standardized. And then we have UNECE. They are sitting together in WP29 working groups, and they build on scenario-based testing, plus road testing, plus simulation, plus proving ground testing. We have ISO standards that are developed dealing with ISO 26262, which is a pretty, I would say, state-of-the-art functional safety standard in to evaluate what happens in case of malfunctions. But if we talk about automated longitudinal lateral dynamics of a vehicle, I mean, that's the core function of a vehicle. That's not enough. So we need SOTIF as an example, safety of the intended functionality. But that's also not enough. Yeah, we also need to think about how does a proving ground need to look like? What scenarios do we need to test for a car that should be deployed from China to Japan to the US? Because that's the business model of the ones who build the cars. They need to sell the cars, otherwise they run out of money. It's pretty simple. So the complexity is so much increasing that I would say no company in the world has enough power to define what is standard. We need to collaborate.
So you mentioned already some good examples for those standardization happening, and it seems like cross industry that those different players get together. I would assume also in their own interest, because if something happens with these vehicles, it certainly helps to say, no, we tested against these standards, and this is assumed the state of the art, and we comply with this like everybody else. Probably much better position than saying, oh, we just did this because we think it's good. So that's also obviously where standards help a lot. But also help me out a little bit. When I look at these standards, for one, they are pretty tedious actually to read. And also I get the impression they describe very often the process, but they don't necessarily say, this is what we call safe. Is that correct, or is also like a more quantifiable thinking evolving now?
Yeah, I think that's a good observation. I think in the past, relying on the process, and if you do everything correct, then the answer will be correct. That is no longer true, because we can't decompose the processes as much anymore, because a lot of the deep learning stuff, for example, isn't decomposable. You open a box and there's a billion ants running around in there, and you can't really put...
What kind of boxes do you work with?
So I think we end up with some kind of driver's license, and like mandated and eventually recommended, like you pointed out in your introduction. I think even though the people that are involved kind of agree that that's the right thing to do, again, the organizational reality of this is that it probably will find counter tendencies in the current companies, because at the moment, and you saw this in the Pegasus project in Germany, where even the participants that were very much for it kind of pulled back and said, oh, not too many scenarios, because then it becomes mandatory, and we have to, and by the way, we don't want to give you hours because they're kind of our IP. And so when you look around here, the research park, all the companies that are here, everybody is basically in a testing and prototyping phase at this point. Nobody is in deployment. Yeah. So the people in charge of those groups are constraining risk. They're not constraining cost or deployment. And so this is a very different kind of engineering optimization, where you keep everything in-house, because you don't want to go to a startup or some other company, or 70-year-old company, because you have to constrain your risk. That means you have to control what the timeline is, what the APIs and interfaces are that you use, what functionality in every part of the whole stack. So that's the sensors, the fusion software, the toolchain of simulation, the HD mapping, everything you want to control, because otherwise you build Jello on top of Jello, and at the top it's just like this. Once you become production ready and you go into the thousands, tens of thousands, hundreds of thousands of vehicles, the people who have, the CFOs are going to come in, the bean counters, the famous Michigan bean counters are going to come in and say, that doesn't fly, well, that's 2 cents too expensive. And so then you start to draw the supply chain out again and start, dispersing risk into the supply chain. I don't think we're there yet.
Okay. So let's see, the audience, please get your questions ready. And just one more maybe here from me, and then we definitely want to get to the audience questions. So the automotive industry is a global undertaking, but do you see something where there are standards evolving more in North American region, others maybe in Europe and some in China or Asia? Or do you see that it's really a global push that is relatively well aligned? So question basically, is it going to be silos in different regions, or can we hope that it's getting relatively global with these standardizations?
Well, I would take the first one on that. And first of all, there are two principles. One is the third-party principle, which you see for certification or type approvals, which practically is based on standards, which is the European or Japanese way of type approving functions or vehicles or whatever. And we have the self-certification like in the US. Definitely, the UNECE and also ISO have the commitment to develop the right metrics, tool chains, and I mentioned several times, to be used in both systems. So there is no way of the one third-party system or self-certification is the right way to go. It's more what's behind it. And we can say that we see that the region, the countries, or let's say take the big ones, USA, Europe, and China as an example, they're opening up. And we are also taking part in something like that, or we have been leading that IAMTS, which has been also introduced briefly together with SAE. And there, besides all political issues which we can see on the planet, there is a collaboration between CATARC, which is the Chinese, let's say, SAE, and the Chinese Standardization Institution, SAE International, IEEE, the German DIN, TÜV, AVL, and so on. And you see there is collaboration starting, and it's really, really catching attention also with OEMs and suppliers and so on, to define the right specifications as a baseline for standardization. Mm-hmm. So I think from silos, we are moving to collaboration slowly, but it's required. Okay. We're getting there.
Anybody else, or do we want to go to the audience?
Yeah, maybe, regulation is, by the nature of it, something that countries like to sit on, right? It's power, and it's something that they can determine, and it gives them a way to influence also industrial policy, for example. So it's not so easy to just wipe that away and kind of start afresh. Nevertheless, the whole industry today realizes we can't do stacks for, Germany, and then for southern Germany, and maybe for northern Italy, and maybe for southern Italy, and maybe for inner London, and I don't know what, right? It's not going to work. And so the desire and the pressure is so high that there is, we see that there is a fair chance that regions will collaborate and find common solutions. Funny thing, though, that I wanted to mention is if you do go out and talk to Dutch people, for example, you'll have the best people who think about bicycles, right? The safety of autonomous driving cars with bicycles. You go to Austria, we think about tunnels. You go to, and Germany, high speed. It's still something that is inherently
almost gone.
High speed between the traffic jams. But it's something that really there is something natural that you come up with best practices given your environment, and also that is something that is very good to collaborate. Right? If you can bring that to the others, then we'll have the best. Then we'll have the best bicycle avoiding cars in the world. Everywhere.
Biker certainly likes that. Very good. Great. Let's see questions from the audience. What's on your mind? Here, can we have a mic? We pass around the mic, and then we go here, and Eric, and then we go further.
So when we look at people, they are getting a driver's license by taking the driving test. So if I'm on the car manufacturer side, I could say that's the bare minimum test an autonomous car needs to pass. And the bar there is pretty low. Like, a human being is getting what, like 70% on that test to be able to drive. But over there we are basically believing in the human brain's capability to learn, as they start driving the car more and more. And I think one of you mentioned something about self-learning, which is obviously helpful. But I think that maybe the manufacturers need to take it, think slightly differently by saying that the car need not be autonomous from the very first day that you buy the car, right? So you start off with something that has the capability to be fully autonomous, but you know, so let's say I'm going to work every day. So maybe after I go to work, from home to work 10 times, the car knows this route, and then it says, okay, now I can drive you there by myself. You don't need to drive it. But so it kind of learns more and more as the person drives it more and more and on different routes. What do you think of that?
That's going to be tricky when you have a traffic jam or an accident on one route and it's late at night after your party and you want to go home and the car goes, I'm sorry, I'm not going to drive anywhere. So
no,
that's...
maybe something to add. Super idea, and maybe we'll get there at some point, but that car you won't be able to pay. There's no chance that you will be able to pay for a car that learns, that has so much computing power that it'll learn its own way of driving. Try.
Never say never, huh? What do you think?
Well,
the other day I was on a panel with quantum computing. Who knows what's in our future, right? Okay, next question.
Hello, I'm from Stanford Medicine. I'm very interested in the benefits of self-driving cars, and testing is definitely necessary, but shouldn't we be thinking about the bigger system, which is transportation, right? I mean, in this hybrid scenario, when we go from 1% autonomous to 2 to 3 to 4, why do we just care about the autonomous side and not try to understand the humans that are also driving, getting themselves adapted to this new system, and try to maximize the benefit for both ends, right? And in terms of disparities, you should worry about that one. And in terms of actually maybe making your own lives easier, if you train the humans, say you teach them to reduce road rage or something by doing something in your car that can actually reduce anxiety or something like that. Wouldn't that be helpful? Because then you have less weird drivers on the street. So I feel like there's a lot of investment that has to be put on testing on these autonomous, but I think it should be testing of the actual system where these autonomous cars are going to be living, and that includes the humans who are also going to be driving. I don't know what you think about that.
I think that's a pretty valid point. Let me put it that way, that first of all, it requires a cultural change. This is why everybody's talking about technology. Yeah, it's always technology, and technology is the thing that enables us to do something or to improve a situation or whatever. But you're right. The psychology of humans and the behavior of humans in an automated vehicle or even a partially automated vehicle and in mixed traffic conditions is key to success, I believe. Because if things happen, we saw this a terrible accident, and there have been several of them. If more of these accidents appear, humans will simply not buy the vehicles. It will not work. Yeah? It will just be a waste of time and money, what happens so far in all the developments. So as a general reaction from my side, I really like your comment that the human being needs to be more considered as a key part still of the full system. And the attention is too low on that so far.
Maybe some work for Stanford Medicine. All right. We go there in the back.
So it seems like with this, I'm Brent Shedd. I run the Self-Driving Cars 101 Meetup, which you should all be members of if you're interested in self-driving cars. So it seems like the direction of a lot of these companies, right, whether it's Waymo or Aurora, et cetera, they're developing a driver, right? And that driver can then be ported, whether it's into a construction vehicle or whether it's into a car or whatever, right? It's this virtual element that gets updated by the intelligence of all the other vehicles. So what I'm curious of is, in a humanitarian thought process, you would think, well, if the driver is really just ones and zeros, right? It's an algorithm. What if, like, nobody makes money until the driver is complete and the driver is completely safe in all the different conditions, like what we talked about, right? So the driver needs to drive in Japan just as well as the driver drives in Omaha, right? So from a thought process, it would make sense for all of these companies to just join together to create this universal driver so they can get about their business of actually getting the vehicles on the road, and they're safe, right? Because you're getting all this, it's this massive Borg hive mind driver that can go into anything and can drive anywhere. That's one concept. I guess another concept would be, or maybe is the future, we have all these hundreds of individual drivers You've got the BMW driver that is the same in every BMW car, and it drives very fast and kind of pissed off all the time and whatever. And it carries all these like cultural dynamics of, I don't really want a Volvo driver, I got to get there quicker. I'm going to go with a Aston Martin driver. Is that how you see this kind of shaking out, or like where does this land exactly? Because we do talk about replicating a human, but we don't really want to replicate a human because humans kind of suck at driving. That's kind of why we're going in this autonomous direction to begin with. So we want something other than that. I'm just curious where, like, is this safety thing? Is this like a, is this a differentiator between these companies?
How human do we want it to be? And is there something like all the companies should develop one driver together?
I don't think, well, that's not really the American model, right? Maybe Bernie model, but how you do it is very competitive, and that's why people are not willing at the moment, after spending billions of dollars in many of these companies, to basically say, oh yeah, here's what we're going to share. Even the accident data is very proprietary at the moment because it discloses much about how they do their work and how their product actually looks like at the moment. However, government or standards or outside shared mechanisms kind of are the boundary, the wall around that, rather than the mechanism itself. And I think that is useful to share. Because we shouldn't drive over another grandmother.
It's obvious when I take a taxi, half of the time I don't like the driver too. There has to be some human component that somebody can tune the system to my liking, because not everybody likes the same driving style. So there has to be a human way, and this is what the colleague from Stanford Medicine said, like there has to be human engineering in this to bring this, to make it comfortable, you driving in this self-driving car. So I don't think, I agree with you, they don't share those, the driver at the end, what we are coming for, that we're measuring how safe that driver is. I think that can be shared.
I would like to also put something on the table here. If you look to the traditional automotive industry as an example, compared to what happens here in Silicon Valley, they are not hunting for level 4 and 5 at the moment. So they want to still, and that's their strategy, to say we want the human, to keep the human as a factor, as a backup, and as a thing, or as an important factor that keeps an eye on traffic and is reacting if necessary. So I think we are far away, at least looking from a global perspective, of having fully automated cars with individual drivers. By the way, I'm driving a BMW. But having a BMW driver, fast, yeah. Sometimes, yes. It's Germany. So I think we are far away from that, and we also have to consider that at the end, the traditional industry is still there. They're earning a hell of a money, and they need to sell cars, and they don't want to have that at the moment. Compared to Waymo, is the one that wants to have that full-fledged individual flash it on any vehicle driver thing. We are far away from that. Even looking at complexity of vehicles at the moment, so impossible, I would say.
Let's see, we have a question here, then there, and then I haven't gotten anything from this side. Am I ignoring you? Okay, then we go to Chris, of course. There, and then Chris.
So, I don't think you should have the same system for all car manufacturers. There's a very old physics jokes. They used to say that they duplicated experiments to make sure that they were correct, and then they would swap the Fortran decks and have the same bugs. Certainly having different systems out there and competing makes a lot of sense, not just from an economic point of view, but from a IP point of view, but also from a safety point of view. But what about in the car? What about having a driving system with a checking system? Are people thinking about having that kind of duplication so that in case of breakdown that the system doesn't completely fail?
I mean, yeah, that's quite commonly applied, let's say. It's you can't put full redundancy in there, but you do that for aerospace, but not yet for automotive. Nobody can afford that. It's in the works, yes. So fail-safe mechanisms and redundancy, etc., etc.
But also simple things like figuring out when a car breaks down or when the police stops a car, there's nobody to talk to. You know, Waymo has to put a number to call on the outside of the window for the police guy.
Yeah, and then there's remote operators that kind of guide your vehicle from a remote. So there's mechanisms that do kind of the same thing without necessarily being fully redundant.
Great. Question there from the back.
Yeah, okay, so I'm actually not very passionate about like really full autonomous cars, and probably we're gonna wait for a long time until we reach to level 5. But now we see like level 2s around, there's a few car companies make that. So can you guys tell us, like, in your estimation, when are we going to reach to full level 3 and 4? When I say full level 3 means that you don't have these restrictions like, okay, you have to drive under 40 miles per hour. So then that's level 4, like 3. So when are we going, to get to level 3 and 4? Yeah.
Anyone guess?
Within this decade?
So that's 10 years.
Level 3 is in the works. It's not going to be that far away, but you'll see it. I mean, the question was 100%, or you won't see that on every car. That will be quite a expensive, monetizable thing.
And also what gets forgotten sometimes, the way as you explain it, if I understand correctly, level 3 would be something, okay, the car drives itself and I can do other things, it will just call me whenever it needs me. Yes, but depending on the ODD, the operating design domain, it can be just level 3 for parking. Yeah. So you don't get any benefit out of it on the highway. So be careful about this. So think about the guy who's asking, well, is this thing safe? Whatever the salesperson might tell you. So level 3 does not automatically mean that you can always enjoy the smooth ride. And
that's what I say is like full level 3. Like you don't get this, like it's level 3 under 30 miles per hour,
Correct, yes. That's what we call ODD, operating design domain, which is also part of this SAE J3016.
There's another point to that question quickly. One thing is technology. That might be relatively easy. The second part is with the regulators have to say, okay, this is the condition when you are allowed to deploy mass production cars with level 3 on the road. And the last, I would say, most important thing, coming to what you said, is the human factor. The people have to buy it, otherwise it's a waste of time and money. So people have to accept it, and if you look at that, how today level 3 cars drive, you get motion sick, you get scared, and just imagine people have to sit their kids or spouses, husbands, wives, whatever, or yourself into that car, and you have to believe it works. Otherwise you will not spend money, and that's the key point, I think, at the end.
And can any one of you tell me, does Audi currently officially say they have level 3 on the market? No. Yes or no? No? Maybe? Don't know. So which is that Audi launched at the International Automotive Show in Frankfurt in 2017, I think, September 2017, that Audi said we have level 3. The only little disclaimer is that we don't enable it because the regulators are not ready for it, which, okay, fine. But that's been now 2.5 years already in the making, and to my knowledge, there's some level 3 parking and maybe traffic jam assist or something like this, but by no means what you were pointing out there, and I can just get in this car and it drives me level 3 to wherever I want. Chris.
Right, Sven, thank you for a fantastic panel. This is more of a philosophical question. Sometimes I believe when we think about or talk about safety, it seems like the perfect is the enemy of good. So what I mean by that is we routinely kill about 36,000 people a year in the US, right? So wouldn't it be nice to introduce these systems? Yes, they will kill far fewer than the 36,000, rather than shooting for 0 deaths on day 1 from the safety point of view. I'm just wondering what your thoughts are.
Are there any lawyers in the house?
The lawyers may leave. We are already in overtime.
it's a perfectly good idea. It's like, and people know it, even like in the airline industry, there are deaths. Last year was a little bit bad one, but like people have to socially accept this again in terms of we have to strive for zero, and in the end, basically what number you put on your liability, the driver software the companies are building becomes liable in terms of then your company is literally killing those people and you are liable for, and then again, the lawyers in the company had to say like, how much do we have to put back for this? How many people are we going to kill this year? Which is very tricky. And this is where society has to adapt over a longer time. And I think that in this decade, starting with a small ODD and then growing it to accept the technology and see how good it really is. Yes, we are strive for perfect, but I think good is hopefully good enough. At one point.
Why wait for 10 years or 15 years for this to happen? So why can't we have this discussion and dialogue all the way from the policy levels and say, yes, we're going to kill few people, but it's going to be a lot fewer than 36,000. Yeah, it's rationally it makes sense. I understand from emotional point of view, it may not. It's very hard, but I think we should start having this discussion. I believe.
But I think from the decade, the one thing that I may not have articulated well enough is you can improve safety with level 2 functions. There's nothing, you don't need to go to a level 3, 4, 5, and with even ODD specific, application specific or situation specific automation, you can already do a lot of good, and that's what is being done. Or people are not waiting to introduce that until everything's ready. So I think we are on that way. It's still pretty difficult to validate, and he can tell you about that.
Well, I would like to come to another point which I can hear more and more, and you can see it on YouTube. You have the Tesla Autopilot and the people sitting on the rear seat, no one on the driver's seat, things like that. So yes, technologically, and besides the validation issue we can theoretically reduce number of accidents by having partially automation like level 2, 2+ or 3. But also the traditional OEMs, if I talk to OEMs in Japan or Korea or Germany as well, they are scared because they say the people start trusting that system and then they pull the smartphone out and start writing emails because they believe that system works. But it doesn't in some particular scenarios, and that is the validation point. We have to make sure that either the car gives restrictions and the system gives restrictions that in particular conditions you cannot drive automated, or the driving function is turned off and you have a big red warning on your dashboard, and so on and so on. So that again makes it very complex, and again the human being is the factor to consider here.
Let's see, we got time for 2 very quick questions there, and let's see.
Hi, you have mentioned that traditional OEMs, for example, the BMWs and the Fords, are currently focusing on level 2, 3, 4 maybe, but having a look at the statistics that we have seen before with all the software driven, I would say, companies focusing on 5 and 6 and putting a lot of resources, time, money into actually maybe even outpacing the traditional OEMs, do you think that that may lead in the long run to a downfall of the BMWs and so on and so forth, just because they're so software driven? Yeah.
Well, I think definitely there's a big change, and definitely the traditional manufacturers are kind of threatened by that in their business models. On the other end, if you look at Waymo, they don't build hardware. They have a pilot, which is a software thing, and that leads to the point at the end. They need each other, I believe. At least for the next decades, I think they need each other. And there might be some traditional OEMs, particularly the smaller ones, which cannot run that big investments and so on. They might disappear or collaborate or whatever. But I think the question of outpacing just by having a concept for level 5, I don't see it, personally.
Okay, 2 very quick there, and then Atul, and then I guess we have to wrap.
Yeah, so we are talking about like maintaining this testing infrastructure and developing the standards, right? But if we have a good standard, that means the standard has already solved the problem. So how do we have a standard to evaluate self-driving if you're trying to tackle the same problem?
I don't understand your question.
So if you have tackled self-driving and if you want to validate it, the standard had to be good enough to test you. That means standard has to be better than you.
I don't think so. Because if you say in sports you have to jump this high, you can jump forward, backward on your handstand. It doesn't imply a particular method, right? Even though it's a perfectly valid threshold for testing.
I mean, that's certainly how the standard is defined, right? If it leaves the solution open, or if a standard prescribes a certain solution, and usually a standard, in my mind, should be something that, as you point out, sets the bar, but then how you accomplish this, let's say crash worthiness, like how do you get like 3, 6, 5 stars actually in a crash test? Well, you can do a lot with the structure of the vehicle, you can do airbags, you can do many other things, but in the end it matters, yes, you have only this relatively low level of force that's introduced to the human body or something like this, and I think...
But standards do have they do influence how people make things.
Yeah.
Dieselgate is a perfect example, right? You build towards that standard, and then a little bit left, a little bit right, boom, everything falls over.
True.
And the same with crash tests, where you had frontal impact was the thing that was tested, and partial impact was not tested, and when they started testing that, the cars just crumpled because they weren't built for that standard. So there is a feedback there, that's true.
Last question.
Thank you. First of all, thanks for an excellent panel. I love the hand grenades that you dropped. Yes. Very interesting and very provocative. So very quickly, thanks for the opportunity to participate in the workshop for these edge reports. Very appreciated very much. And yes, and we at Momentum, we all also participate in the IMTS consortium. So we are happy to work on projects with regional differences. Very, very keen to make progress on those. My question is, so far we've been talking mostly about prototypes and how to get prototypes to deployment. But let's say we already are at the stage where we have some level 4 vehicles. Today's news where Neuro's exemptions have been approved by FMVSS, so we might see these delivery vehicles on the roads. The question is, how should maybe regulators or consumers think of monitoring these vehicles that are on the road, especially with all the hybrid traffic in the picture, right? Alex, you're talking about automation-induced distraction, right? People texting and sleeping in their vehicles while driving. So how should companies and even testers think of this continuous monitoring? Because driving capability will grow over time, as we've seen. There'll be level 2s, partial level 3s, some level 4s. How should we think about that?
Well, for one, there's a lot of investment going on into human monitoring. So watching the driver or the passenger and understanding in which state of mind he is and in which state of alertness he is, and so on and so on. So that's one thing of doing that. I think also the regulator has quite a bit of interest, and you guys should talk over the aisle here, but has quite a bit of interest to understand how things work together between man and machine there. So there'll be monitoring from that angle. If you go to China, you're pretty well monitored these days. Right?
Problem solved.
Crazily, yeah.
But we've only talked about the car or the driver within the car, but coming back to your point, humans are part of a system, and there are other drivers, and if should we actually put blinking red lights when a car or a Neuro is driving self-driving, so that other people are aware, like it says school zone, you're aware, you drive a little bit more slowly. A lot of the accidents in San Francisco, I shouldn't say who, but are these things where people drive into the back of a car because they didn't really think that was a self-driving car, and they don't take any action. They assume it drives like a normal person, and that assumption is often wrong.
And the next thing you'll have, if you have the little red light, then school children jump in front of that car because they know this car always has to stop.
Well, that's self-selective.
All right.
And people do that. People drive behind the Waymo cars and try to,
push them a bit. Yeah.
All right. Thanks very much to our panelists, and thanks for great questions. Thanks very much.